This is the procedure for the Calorimetry and Hess's Law lab. I'm going to start just by pointing out some tips that you're going to need in the lab during the three reactions. So the first is all masses should be measured to the scale that reads to 0.01 grams. Second thing, use separate graduated cylinders for reaction 1 for the HCl solution and the NaOH solution. So don't use the same graduated cylinder to measure both of those. And those graduated cylinders, you're going to measure the volume to 0.1 milliliters. All temperatures using the thermometer should be to 0.1 degrees Celsius. Number 4, after you mix whatever you're mixing in each reaction, don't just stir it once, keep it stirred constantly. Watch the thermometer and the temperature. It's exothermic in all cases, all three reactions, so the temperature will keep rising as long as you keep stirring, but when it finally stops rising, if you're still stirring, then you know the reaction is done and you can write down the highest temperature that you get to. So make sure you stir constantly, but it's very important to keep the lid on tight while you're stirring, so there's a hole in the lid that the thermometer fits through. So as you stir, make sure you don't drag the lid off to expose your solution to the air, or heat can escape. And the other thing, which is very easy to do, is to poke a hole in the styrofoam cups that the reaction's going on in. So be very careful not to poke a hole in the cups while you stir. But do keep it stirred constantly the entire time the reaction's going until you reach the highest temperature. Last thing, fifth thing, is you're going to use naoh pellets in reactions 2 and 3, but they're hygroscopic. That means if they're exposed to air, they can absorb water vapor from the air, just like a sponge. So the longer they're exposed, the more water vapor gets absorbed, which of course affects the mass. So make sure you keep the cap on the vial of naoh pellets at all times, except when you're adding them to the mixture for the reaction to happen. So just a split second while it's being added, but otherwise keep the cap on. So reaction 1 is reacting a solution of NaOH with a solution of HCl. Same reaction you did in the titration lab, except this time we're trying to figure out delta H for this reaction. So you're going to start by putting 2 styrofoam cups together, one inside the other. So tear the scale and then put those cups, the double cup, together and get the mass. Again, all masses to the nearest 0.01 gram. Then you're going to take a graduated cylinder and measure about 45 milliliters of 1.0 molar HCl, and you're going to again do that volume to the nearest 0.1 milliliters. Then stick a thermometer in your HCl and get the initial temperature. You can assume the NaOH temperature is the same as the HCl since they're both out on the counter at room temperature, so whatever you have for the HCl and the NaOH will be the same, and you can just call that the initial temperature. So now your cup's ready to go with the HCl. Using the second graduated cylinder, a separate one, not the one you use for the HCl, you want to measure out about 40 milliliters of NaOH to the nearest 0.1 milliliter. You use less NaOH because you want it to be the limiting reagent. And you get your cylinder ready, you've got the volume, and you pour it into the cup with the HCl. You put the lid on tight and you start stirring, and you stir constantly and watch the thermometer go up until you get to the highest temperature that it'll get to, and once it stops rising, you're done. So all waste from this can just go down the sink when you're done, but make sure before you dump out the contents of the cups, you want to weigh the cups together with the solution mixture that's in there. So go back to the scales, tear the scale to make it say 0, and drop the cup with the solution on there and get the mass to the nearest 0.1 grams. And that's everything you'll need to do the calculations to get delta H for reaction 1. Reaction 2 is simply dissolving solid NaOH in water to make an NaOH solution or an aqueous solution. Water itself actually is not a reactant. It's obviously present to help with the dissolving process, but it's not actually a reactant. So you shouldn't show it when you write the chemical reaction. First thing you do, take the same double styrofoam cups. You've dumped out the waste from reaction 1. You've rinsed it out thoroughly multiple times. Let it get back down to room temperature. And then you tare it, so it says 0, and then you can take a squeeze bottle of distilled water and add distilled water until you get to about 100 grams. So it doesn't have to be exactly 100, it can be anywhere around there. Don't spend too much time trying to get 100. And just write down the mass to 0.01 grams of the water in the cup. So whatever you add, the scale after you tare it will give you the exact mass of distilled water in the cup to start with. Then you take the initial temperature of the water to start, and then you will have a vial of solid NaOH with the cap on it. Remember, it's hygroscopic, so you got to keep the cap on it, and you get the mass of that vial. And also shake it up so that the pellets are separated from each other. You don't want a huge clump of pellets stuck together, because you're going to use half for this experiment and half for the next reaction, reaction 3. So get the mass of the NaOH pellets in the vial with the cap on it. Then quickly open the cap and add about half the pellets, so you can eyeball it, just estimate about how many are in there, and add about half the pellets to the cup of water. And as usual, first of all, put the cap back on immediately so no more water vapor can get in. And add the NaOH to the cup of water and start stirring. And keep stirring, don't poke a hole in the cup until you get to the highest temperature you can get. When it stops rising, you're done. Waste down the sink, rinse out the cups again for the next experiment. And last thing you want to do is make sure you get the mass of the vial with the cap on it, which now, of course, has half as much NaOH in it as before. And then we're on to reaction 3, which looks very similar to reaction 1, except now the NaOH you're using is solid, so it's going to be the rest of those pellets that are in the vial. So just like the last time, reaction 2, you're going to tare your double cups first. So now the cups are on the scale, but it says 0, and then you can pour in HCl solution, 1 molar HCl, until you get to about 100 grams. And again, it doesn't have to be 100. Anything near 100 will do. Just write down the mass you use to 0.01 grams. And then, just like last time, get the temperature of that HCl in the cup. Then you're ready to go. Open the cap and add the rest of the solid NaOH pellets. So just whatever else is in there, just dump it right in. Start stirring. Keep the lid on tight and get to the highest temperature you can reach. And when it stops, you're done. You can dump out the waste, rinse out the cups, and you're done with your measurements for the day, except you want to go over the scales one more time and grab the mass of the empty vial with the cap on it. Since all your other measurements included the mass of the cap, make sure the vial has the cap on it when you do that final measurement. So you now have everything you need to find delta H for each of the 3 reactions. So all of them, I've written the equations here for all 3. All of them are exothermic, so you know your delta H is going to come out negative. First reaction, the grams of solution is just simply the mass of the cups and the solution at the end minus the mass of the cups themselves, so you get that one by subtraction. The specific heat of the solution you're going to assume is the same as water, so 4.18. And of course you measured this difference, final minus initial temperature. On the denominator, you're going to take the liters times molarity to get the moles of the limiting reagent, NaOH, and put that on the bottom. So that's going to be in joules per mole, and you'll want to convert that at the end to kilojoules per mole. That's going to be the case for reactions 2 and 3 as well. It comes out in joules per mole, so make sure you convert it to kilojoules per mole at the end. So reaction 2, also exothermic, but this time you're going to get the mass of solution by simply adding the mass of the pellets you dumped out from the vial plus the mass of the water. So this part you're going to need to subtract to get that mass of the NaOH solid, and just simply add it to the water mass to get the total mass of solution in the cup. Then this part's the same, 4.18, temperature change you measured. The moles this time you're going to do differently. You're going to take the mass of the solid NaOH pellets that you added and divide by the molar mass to get moles of NaOH. That'll come out in joules per mole, and you switch it to kilojoules per mole, and there's delta H of reaction 2. Reaction 3 this time looks very much like reaction 2, except it's the mass of the NaOH pellets that you added plus the mass of the HCl solution that you put in the cup at the beginning. So you have that mass on your data table. So you add those up to get the total mass of solution in the cup. Specific heat of water again, temperature change as usual, and the denominator is the same as reaction 2. You just take the grams of NaOH pellets. This time you get these by subtraction of the half full vial and the empty vial. Will give you that mass, and you convert it to moles. And that'll give you joules per mole for delta H3, and you convert it to kilojoules per mole. So now we have delta H of these three reactions. If you look back at the chemical formulas, you'll see that when you add reaction 1 and 2, they add up algebraically to reaction 3 because NaOH aqueous cancels out of the equation. So Hess's law says that delta H1 plus delta H2 should equal delta H3. Your job is to actually do the math. Find delta H1 and 2, the sum of that, and see if it equals delta H3. And if it doesn't, there's some pretty likely sources of error for why those might not be equal that you can discuss as part of your lab report. So that's everything you need to do the lab. Just be careful to keep the lid on tight. Stir constantly, don't poke a hole in the bottom of the thermometer, and of course make sure you get all the measurements for the data table before dumping out the final solution. So that's it. Good luck, and we'll see you in the lab.